In today's lesson, we will cover the earthquake issue in detail. Enjoy watching. What is earthquake? An earthquake is a sudden and rapid shaking of the ground caused by the movement of tectonic plates in the Earth's crust. It can cause significant damage to buildings, infrastructure, and loss of life. Earthquakes can occur anywhere in the world and their frequency and strength can vary greatly. Earthquake waves. Earthquake waves are the seismic waves generated by the movement of tectonic plates along a fault line. There are two main types of earthquake waves: P waves, primary waves, and S waves, secondary waves. P waves are compressional waves that move through the Earth's interior and are the fastest of the two types of waves. S waves are shear waves that move through solids only and are slower than P waves. There are also other types of seismic waves, including surface waves, which move along the Earth's surface and are the slowest but largest and most damaging of the seismic waves. The study of earthquake waves is an important area of research for seismologists, who use this information to better understand the Earth's interior, the nature of earthquakes, and to make more accurate predictions about future earthquakes. What is earthquake P wave? P waves, also known as primary waves, are one of two main types of seismic waves generated by an earthquake. They are compressional waves that travel through the Earth's interior and are the fastest of the two types of seismic waves. P waves can move through solids, liquids, and gases and cause the ground to move in a back-and-forth or push-pull motion. These waves are used by seismologists to determine the location and magnitude of an earthquake. What is earthquake S wave? S waves, also known as secondary waves, are the second type of seismic waves generated by an earthquake. Unlike P waves, S waves can only travel through solids and cause the ground to move in a side-to-side motion. S waves are slower than P waves and are usually larger and more destructive. The arrival time of S waves is used to determine the distance of the earthquake from the seismographic station. The properties of S waves provide important information about the structure and composition of the Earth's interior. What is earthquake map? An earthquake map is a graphical representation of earthquakes that have occurred in a specific region or the world. The map usually displays information such as the location, magnitude, and date of each earthquake. Some earthquake maps also show the intensity of ground shaking, tectonic plate boundaries, and historical earthquake activity. Earthquake maps can be useful for seismologists, engineers, and emergency management officials to better understand the pattern and frequency of earthquakes in a given area, and to prepare for future events. Earthquake maps can be found on various websites, including those maintained by government agencies and universities. What is earthquake fault line? A fault line is a crack in the Earth's crust along which two tectonic plates move relative to each other. Earthquakes occur when there is sudden movement along the fault line, releasing built-up tension in the Earth's crust. Fault lines can be found all over the world and can range from a few centimeters to hundreds of kilometers in length. Some of the most active and well-known fault lines include the San Andreas Fault in California, the North Anatolian Fault in Turkey, and the Alpine Fault in New Zealand. The study of fault lines and their associated earthquakes is an important area of research for seismologists, who use this information to better understand the Earth's interior and to help predict and prepare for future earthquakes. Earthquake forecast. An earthquake forecast is a prediction of the likelihood and timing of future earthquakes in a specific region. While it is not currently possible to predict earthquakes with exact precision, there are methods for assessing the probability of earthquakes in a given area over a specified period of time. These forecasts are based on various factors such as past earthquake activity, plate tectonics, and changes in strain in the Earth's crust. Earthquake forecasts can be useful for planning and preparedness purposes, but it is important to understand that they are not exact predictions and the actual likelihood and timing of earthquakes can still be uncertain. Additionally, large and damaging earthquakes can still occur without warning, so it is important for individuals and communities to be prepared at all times. What is earthquake epicenter? The epicenter of an earthquake is the point on the Earth's surface directly above the focus, which is the location within the Earth where the earthquake originates. The epicenter is the place where the ground shaking is the strongest and where most of the damage from the earthquake occurs. Seismologists use data from seismographic stations to determine the location of the epicenter, and from that information, they can also determine the magnitude and depth of the earthquake. The epicenter is an important location for understanding the impact of an earthquake and for making predictions about future earthquakes in the same region. What are earthquake causes and effects? The primary cause of earthquakes is the movement of tectonic plates in the Earth's crust. Tectonic plates are large pieces of the Earth's lithosphere that move relative to each other, and earthquakes occur when there is sudden movement along the boundary between two plates. Earthquakes can also be caused by human activities such as underground nuclear testing, the construction of large dams, and the pumping of fluid into deep underground wells. The effects of earthquakes can be significant and far-reaching. They can cause damage to buildings and infrastructure, trigger landslides and tsunamis, and result in loss of life and injury. Earthquakes can also have longer-term effects such as economic disruption, social displacement, and psychological trauma. In addition, earthquakes can lead to fires, power outages, and communication disruptions, making the aftermath of an earthquake particularly challenging. It is important for individuals, communities, and governments to be prepared for earthquakes and to have plans in place for responding to and recovering from earthquakes. What is earthquake magnitude? Earthquake magnitude is a measure of the size or strength of an earthquake. It is determined by the amplitude, or height, of the seismic waves generated by the earthquake, and is usually expressed as a number on the Richter scale. The Richter scale is logarithmic, meaning that an increase of 1 unit on the scale corresponds to a tenfold increase in the amplitude of the seismic waves. Earthquake magnitude is an important factor in determining the potential damage and impact of an earthquake. In general, larger earthquakes are more destructive and can have a greater impact on the environment and human communities. The magnitude of an earthquake is also used to compare the size of different earthquakes and to track changes in seismic activity over time. It is important to note that earthquake magnitude is not the same as earthquake intensity, which is a measure of the amount of ground shaking and damage caused by an earthquake at a particular location. Earthquake estimate. The estimation of an earthquake refers to the process of determining the magnitude, location, and other characteristics of an earthquake. This is typically done by seismologists using data from seismographic stations. The seismographic data is analyzed to determine the magnitude, depth, and epicenter of the earthquake, as well as the type and direction of the seismic waves that were generated. This information is then used to create maps and visualizations of the earthquake, which can help to understand its impact and to make predictions about future earthquakes in the same region. In addition to seismographic data, seismologists can also use other sources of information such as eyewitness reports, damage assessments, and satellite imagery to estimate the impact of an earthquake. The estimate of an earthquake is an important aspect of earthquake research and helps to inform disaster response and preparedness efforts. Earthquake measurement. The measurement of an earthquake refers to the process of determining its magnitude, location, and other characteristics. This is typically done using seismographic data, which is collected by seismographic stations located throughout the world. The seismographic data is analyzed to determine the magnitude, depth, and epicenter of the earthquake, as well as the type and direction of the seismic waves that were generated. There are several different scales that are used to measure earthquakes, including the Richter scale, the moment magnitude scale, and the Mercalli intensity scale. The Richter scale is a logarithmic scale that measures the magnitude of an earthquake based on the amplitude, or height, of the seismic waves that were generated. The moment magnitude scale is based on the amount of energy released by an earthquake, while the Mercalli intensity scale is a qualitative measure of the amount of ground shaking and damage caused by an earthquake at a particular location. In addition to seismographic data, seismologists can also use other sources of information such as eyewitness reports, damage assessments, and satellite imagery to measure the impact of an earthquake. The measurement of earthquakes is an important aspect of earthquake research and helps to inform disaster response and preparedness efforts. For the continuation of the videos, do not forget to subscribe to my channel, turn on notifications, like my videos and write a comment under my videos.